Hi, and this is section 10-2. We're on page 635, and this section is entitled Graphing y equals ax squared plus bx plus c. Now, we just, over the weekend, watched a video where we were learning how to sketch y equals ax squared plus c. There was no b value. So what you're going to see today is a lot of the things I talked on that video. I tried to introduce a lot of things in the last video, which is why it was so long, to make this video easier and this section easier and this video shorter. Remember, when we talk graph, we're really going to sketch. In fact, I'm going to cross out graph. We want to sketch these, okay? We're not looking to take out graph paper and plot points and all that. We're just looking to sketch these. When we sketch, I'm going to ask you to do the following things. So when I quiz you on this, this is what I'm going to look for on your sketches. You're going to do the following. This is my pen unfreezes. We're going to make an accurate drawing of the parabola. Accurate means it's going to be reasonably neat. You're going to label the vertex of your parabola. You're going to label the axis of symmetry on your parabola. We talked about axis of symmetry in the last video. We will discuss it more in this video. You are going to label two other points on your parabola, and we're also going to identify your parabola as having a maximum or a minimum value, and you're going to tell me what that maximum or minimum is. We did all this on our last assignment, except I really didn't emphasize as much labeling the axis of symmetry maybe. I'm going to make sure I emphasize that heavily today. That's something I would want to see on your drawings. Okay? So, moving on. So how is the graph of y equals ax squared plus bx plus c different from the graph of y equals ax squared plus c? Now remember, this is what we covered back in 10.1 right here. This is what we covered in 10.1. And this is what we're covering in 10.2. So how are these different? Well, the big thing is when a quadratic has no b value like we did early in the week, Monday, like in 10.1, the parabola always would have an axis of symmetry on the y-axis, or x equals 0. In other words, if there's no b value, when you graph this, it's going to look like this. And let me quickly draw it out. Draw a little sketch. If there's no b value, let me just kind of sketch a little graph off to the side. Your axis of symmetry will always be, and let me do dotted line, it's always going to be right here. It's always going to be right on the y-axis, so your parabola's vertex will always be right on the y-axis. It's going to be, you know, a graph such as that, or maybe if it's opening down, it would be here. Its vertex is always on the y-axis if there's no b value, because think about it. Remember, we talked about this formula in the last video. If there is no b value, b is 0, and as soon as you plug a 0 in here, 0 divided by anything is 0. The axis of symmetry is x equals 0. All right? However, if you do have a b value, when a quadratic does have a b value, it normally means the parabola is being shifted left or right, and its axis of symmetry then is also being shifted left or right. Now, a positive b value doesn't necessarily mean the parabola is shifted to the right, and a negative b value does not necessarily mean it's being shifted to the left. It all depends. So you actually just use this little formula to find where is the axis of symmetry. But a b value would tell you for certain it's shifting one way or the other. Remember, the axis of symmetry always passes through the vertex of the parabola. Now, this is where the vocabulary comes in. If you look at this picture, my axis of symmetry, the vertex is always on that. So in other words, maybe I should just draw a little diagram to show you what I'm referring to. That means what this statement that I'm starring, what that statement is telling us is the following. If you have, let me draw a little picture here, a little sketch, okay? What this little statement is telling me is that if your axis of symmetry is over, let's say over here, it would be impossible for you to have your parabola, for example, over here, because the vertex has to be on the axis of symmetry. So this is not possible, okay? The axis of symmetry always passes through the vertex. So this picture is not a possible picture because the vertex is not on the axis of symmetry, all right? And finally, in relation to our last section and our last video, A and C still tell us the same things. A will tell us if the parabola opens up or down, is it stretched or is it shrunk. C is still where the parabola will cross or touch the y-axis. Now, when there's no B value, the parabola always touched the y-axis or intercepted the y-axis at the vertex. When there is a B value, the parabola will still intersect the y-axis, but no longer at the vertex, just at another point, okay? So I think the best thing to do is just to walk through some sketches here and actually walk through how we're going to sketch these. So how do I find the axis of symmetry and vertex for a quadratic with a B value? Well, I think the best thing to do is just to walk through some. Remember, we're going to use the formula, use B and A, to find the axis of symmetry, all right? So let's say that we want to sketch y equals negative 2x squared plus 12x minus 7. You notice there is a B value. So as soon as I see the B value in my mind as I'm sitting here at my desk and I'm thinking, okay, here's my little thinking bubble, as soon as I see a B value, I'm thinking axis of symmetry is shifted left or right. Okay, I'll just put L or R. Okay, I don't know which way it's shifting. I got to use the formula to figure that out. But I know the axis of symmetry is not going to be right on the y-axis anymore. It's going to be shifted. So let's actually figure it out. Let's take 12, plug it in for B. I got negative 12 over 2 times negative 2, and I found out x equals 3. So now when I go to graph this, I'm going to draw an xy axis, and you can see that below, and here is my axis of symmetry. All right? Now I want to find the vertex. Now remember, the vertex is right on the axis of symmetry. So that means the vertex must be the point 3 something, okay? The vertex, remember, let's define the vertex again. When you have a parabola, either opening down or opening up, the vertex is that either bottom or top point. Well, this parabola, the vertex is intersecting right here 3 units over on the axis of symmetry. Now to find that point, all I need to do, since x, remember this axis of symmetry is x equals 3, all I need to do is take x equals 3 and plug in 3 for x in each case here to find y. So let's do that. Let's take 3 and plug it in here. 3 squared is 9, and negative 2 times 9 is negative 18. And 12 times 3 is 36, and then I got to subtract 7. So I have negative 18 plus 36, which is 18. 18 minus 7 is 11. So that's where I'm getting y equals 11. If I plug in 3 for x, y must be 11. So the vertex, that's why I have this written here, the vertex must be 3 right, 11 up. All right? Here's the next thing to consider, okay? Is the parabola itself now opening up or down? So here's I got to move to a new slide just so I have a clean page. Okay? Now that I have the vertex drawn, is the parabola opening up or down? Well, look right here. My A value is a negative, okay? It's going to open down, and you notice how my C value is negative 7. That means I have an intercept at the point 0, negative 7. Remember, y-intercept means when I see negative 7, what that's telling me is that at 0, negative 7, this parabola must intersect that point. So I know my parabola is opening down, and you can see that here. Okay, you can see that this point means it's opening down, so now I can sketch it. And I guess one more thing, I got a little ahead of myself. I know it's opening down, I want to sketch it. This axis of symmetry is x equals 3, and this is the point 0, negative 7. the distance from here to here is 3 units, right? From 0 to 3. The axis of symmetry acts like a mirror, and remember, parabolas are always have an axis of symmetry. They're mirrored. So if the point 0, -7 is on my parabola, then if I go 3 units over and mirror here, that means the point 6, -7 should also be on my parabola. Okay, let me just erase that out. I don't need all that stuff in there. Okay, but I just wanted to go through how I'm getting the point 6, -7 also on my parabola. And as I said from the beginning, this is opening down, so I can open it down. It's got a stretch. Is A positive or negative? It's negative, so it's opening down. It's being stretched a little bit, and that's what I'm writing here. And now I can finish sketching. Okay, so my sketch is going to look something like that. I hope I did a good job of explaining that and that makes sense to you. Okay, let's do another one. Number 16 on page 638. Here's my quadratic. Okay, step 1, let's get our axis of symmetry. B is 4, A is 1. My axis of symmetry is -2. So I'm going to go ahead, draw my xy axis. Here's my axis of symmetry. Now remember, the vertex must be on this axis of symmetry. Let's find the vertex. So take -2 for x, and since the axis of symmetry is at -2, take -2 for x, take that, and let's go ahead and plug that in for x. And that's what I'm writing down here. So -2 squared is 4. 4 times -2 is -8, and then I'm adding 8. Well, 4 plus -8 plus 8 is 4. So my vertex must be 2 left, 4 up. There's my axis of symmetry, there's my vertex. Lead coefficient's 1, so I know this parabola is going to open up. C, can you see that C equals 8? That means the point 0,8 is on this graph. So if this is the point -2,4, 0,8 is also on this graph, which I'm plotting. And remember, the axis of symmetry acts like a mirror. So since the axis of symmetry is 2 units left, the distance from the axis of symmetry to this point is 2 units, right? If this is -2 and this is 0, that's a 2-unit difference. So it's 2 units here, which means this point is 2 units to the left of the axis of symmetry, which must be at -4,8. I know this is opening up because I got a positive lead coefficient, and so there's my sketch. My sketch is, I have 3 points labeled, -2,4, 0,8, and -4,8. I have my axis of symmetry labeled at x equals -2. This is opening up. This graph has a minimum of 4. I probably should have pointed that out on my last graph also. I never did point out this graph had a maximum of 11. Remember, we always want to label our minimum or maximum. I didn't mention that on this prior problem. Okay? Let's try another one. Y equals -x squared minus 10x. Let me add something to that because there's really plus nothing here. Okay? So first of all, let's get our axis of symmetry. Plug in -10 for B, and plug in -1 for A. And when you do that, the opposite of -10 is 10 on top, and I got -2 on the bottom. 10 over -2 is -5. So there's my axis of symmetry. I don't know why I wrote that in there. We'll get to that later. Okay? Now I got to get the vertex. Now remember, to find the vertex, since x is -5, simply take -5 and plug it in for x. And when you do that, you will find that when you plug in -5 for x, that y became 25. Through simple calculation, just plug in -5 for x and solve. You get y is 25. So I just learned that my vertex at -5, 25, which would be up here somewhere. Now here's the next thing. I know this is opening down. Okay, A is -1, so I know this is opening down. C equals 0. Can you see that? which means I have a point at 0, 0. Well, if I have a point at 0, 0, if the axis of symmetry is 5 units away, can you see 5 units here? 5 units away, that means there must be a mirrored point 5 units on the other side of the axis of symmetry. That would have to be at negative 10, 0. So let me just erase those out. So I hope that's making sense as to why if I have 0, 0, I got to mirror a point over here, which would be at negative 10, 0. And I told you this is opening down, so I can go ahead and just sketch that as best I can. Now remember, it should look semi-neat. I'm not doing too bad there. It's going to look something like that. Okay? Wrapping up here. Remember, if A is positive, the parabola will have a minimum value. Let's think about that for a minute. Okay? A was positive. That means the parabola opens up. If the parabola opens up, it has to have a minimum or a lower end, because it's opening up. It never stops opening up. It'll go up forever. So it has a minimum if A is positive. If A is negative, then our parabola has to have a maximum because the parabola is opening down. That means it will have one high point, and from there on it just keeps on going down forever. Okay? That's why in the problem we just did, this, and I have to finish up, I haven't finished this yet, in the problem we just did, this problem has a maximum. The parabola is opening down, the maximum is 25. So I did do all 5 things that I asked at the beginning of the video on this problem. I made a respectable looking sketch. I have my axis of symmetry. I labeled my vertex. I labeled 2 other points. I told you if it has a maximum or a minimum and what that maximum or minimum is. Okay? And that's all my last point was here. If A is positive, the parabola will have a minimum value because the parabola opens up. If A is negative, the parabola will have a maximum value because it's opening down. The y value of the vertex is just that maximum or minimum. So what I mean here is you see the y value of my vertex is my maximum. Can you tell on the prior slide, the y value of my vertex ended up being the minimum? Can you see on the problem before that, my vertex was 311 and the y value of the vertex ended up being the maximum value? Okay? That's about all I need to do for this video. Like I said, the last one was longer. This one didn't need to be as long, and it's not. All right? So we will audit tomorrow, and we can go over questions tomorrow.